Hi all. So as I said at the end of the last lecture, this lecture we're going to be talking about a specific negative feedback loop that's actually two separate feedback loops connected to one another. So what I mean by that is that the body has one way to deal with high blood sugar and another way to deal with low blood sugar, and they balance each other out. So first we're going to talk about how the body deals with high blood sugar. So in order to deal with high blood sugar, we have to look at the pancreas. Pancreas is an organ that is tucked behind the stomach. It's also wrapped around the small intestine, as you see here. And the pancreas has two types of functions. It has an endocrine function and an exocrine function. So an endocrine function means that a tissue in the body is communicating with another tissue that is really far away. So it's not neighboring, but it has to travel through the bloodstream to get there. And we call the signaling molecules that regulate this kind of signaling hormones. And so an example of a hormone is testosterone. And during male puberty, people have a large spike of testosterone, and that affects all over their body. So for instance, they may gain more muscle mass, their faces might become more oily, they might grow a beard, their voices might drop. These changes happen all over the body. It's a global change. And testosterone has to travel through blood in order to cause these global changes in all these different kinds of parts of the body. An exocrine function is a function that happens within an organ or tissue or a neighboring organ or tissue. And so the endocrine function of the pancreas is to regulate blood sugar levels, and the exocrine function is to neutralize acid and provide digestive enzymes to the small intestine, because again, the small intestine is right here. But since regulating blood sugar levels has to do with the blood, which is all over the body, it also has to do with the liver, which is not next to the pancreas. This is considered an endocrine function. It's governed by hormones. So what hormones are we talking about? Let's zoom in to one of these little nodules on the pancreas, and these are called the islets of Langerhans. So surrounding the islets of Langerhans, we have these exocrine cells, and again, the exocrine pancreas is working with the small intestine, decreasing stomach acid, making sure that it's absorbing food correctly, and the cells that we're going to really be talking about, which are all the endocrine cells, which are these four different types. We're going to talk about two of them in detail, the alpha and beta cells, and a little bit about the delta cells. So don't worry about the F cells here. So again, the islets of Langerhans, they exist to control the endocrine function of the pancreas. So they control how hormones are released in the pancreas and into the bloodstream. So first, we're going to be talking about beta cells. And beta cells secrete insulin. We're also going to talk about alpha cells, which secrete glucagon, and delta cells, which secrete somatostatin. So insulin has the job of decreasing glucose and fatty acid in the bloodstream. So insulin goes out from the pancreas into the bloodstream and then has several different roles in the body, which we'll discuss. But it goes out from the pancreas into the bloodstream, which is why it's a hormone and governs endocrine function. So as we said, when we have high blood sugar, we're following this red pathway here, and the pancreas releases insulin, specifically the beta cells of the pancreas release insulin, and then insulin does 3 different things. First, it brings glucose into cells, and so there needs to be a way that things that are in the bloodstream actually go into cells, and so this is what we're talking about. And so this is the outside of the cell, and this membrane is the cell membrane, and this is into a cell. And so these tissues could be anywhere in the body. So they could be heart tissue, they could be lung tissue, they could even be liver tissue or pancreas tissue. And so first the insulin comes into an insulin receptor, which is on the cell membrane of this tissue cell, of this cell, wherever in the body you want it to be. And the first thing it's going to do once it gets in is it's going to allow all of this glucose, all of this sugar from the blood into this cell. And then there are a couple of other things that it's going to do. First, it's going to take these glucose to turn into glycogen. And this is in the liver, and we're going to talk about this a little bit more. It also takes glucose and turns it into ATP, because glucose is not actually the currency that your cells use for energy. They use ATP to drive all of your cellular processes. It's what the mitochondria uses to use the energy in your cells. We also have this transformation to fatty acids, and so this is what happens when the rest of the glucose in your blood has been used for other mechanisms, and so it needs to store the rest of your blood. And so this is why we associate with maybe a high sugar diet with lots of fat, lots of fatty acids, because the sugar has stored into this fat. So again, insulin can work in tissue cells, bringing the sugar into tissues out of the bloodstream, and it can turn that into fatty acids, but it can also stimulate glycogen formation. And so glycogen is these long chains of glucose molecules. It's also called starch. And so this is a glucose molecule, and this is a glycogen. this is a way for the body to store all of that sugar and save it for a time that it might need some sugar. And so the insulin travels through the bloodstream to the liver, and the liver starts this process of glycogenesis, which is making this glycogen out of glucose molecules. And the effect of both of these is to lower blood sugar. Insulin lowers blood sugar in tissue through tissue cell, bringing the sugar into tissue cells, so it's out of the bloodstream, and also by stimulating glycogen formation, because at that point the glucose is no longer glucose, it's in these glycogen chains, and so that also brings sugar out of the blood. Now we're going to talk about what happens in the context of a negative feedback loop. So we have our stimulus. So a person eats and their blood sugar is high, especially if it's a sugary food. So say it's a candy bar that this person is eating. Then we have our sensor, which is our pancreas, and the pancreas is going to release insulin into the blood. This serves as a control because tissues are going to take glucose and the liver is going to turn glucose into glycogen. That's what happens to change things. And what changes is the blood sugar drops. And then again, we have to ask this question: has the blood sugar dropped below what we need to consider high blood sugar? And if it has, then we're going to stop this loop. If not, we can continue on this loop because the blood sugar is still high. So next, we're going to talk about what happens when we have low blood sugar. And now we're following this blue pathway here. So again, we're also dealing with the organ of the pancreas. But let's look again. Now we're dealing with alpha cells. And they secrete a hormone called glucagon. And glucagon's job is to raise the concentration of glucose and fatty acid in the bloodstream. So it functions as basically the opposite of insulin. So insulin decreases glucose and fatty acid in the bloodstream, and glucagon increases glucose and fatty acid in the bloodstream. Again, we also have these delta cells that suppress both, so we don't end up in an arms race of more and more and more glucagon and insulin to where that becomes dysregulated itself. So even the regulators have a regulator. So glucagon is released not actually directly in response to sugar levels in the blood, but actually in response to levels of insulin in the blood. And why can the body do that? So it's much easier to track insulin in the blood than it is actually to track sugar in the blood. And this serves as a proxy. So the level of insulin in the blood is pretty similar to the level of sugar in the blood, because insulin is taking sugar into cells for how much sugar there is, right? It's a proportional mechanism. And so if there is enough insulin, then you might think, oh, okay, the glucagon will think, okay, this is fine. There's already enough sugar in the cells. But if the level of insulin is really, really low, then we have a problem. We need to release glucagon and start this other cascade. So glucagon also travels to the liver, and it works in this pathway. So it breaks glycogen down into glucose. And if we remember, glycogen is these long chains, and glucose is this usable subunit here. And so let's think about what's going to happen when that glucose gets released from the glycogen chains. So we can follow the red arrow again. So when we have blood sugar again, like high blood sugar again, then the pancreas is going to release insulin. It's going to take that sugar into cells, and then cells can transform it into ATP to use it as energy, and also into fatty acids, which the body also needs. So by doing both of these things, the blue pathway is taking low blood sugar to raising blood sugar through alpha cells in the pancreas, releasing glucagon, which breaks down glycogen into glucose. And what is glucose going to do when it's back in the bloodstream? After this blood sugar is raised, it's going to promote the release of insulin by beta cells and make it possible to take glucose into these tissue cells and turn them into ATP, which they can then use for energy. So if we're to talk through this negative feedback loop, the stimulus is someone who hasn't eaten for a long time, their blood sugar might be low, they might have a headache or be really hungry. So the sensor is again the pancreas, specifically the alpha cells this time. They're going to release glucagon, the hormone, into blood. And our control is what happens because of this glucagon being released into the blood. And that's that the liver turns glycogen into glucose, and glucose goes into the bloodstream, and the blood sugar raises. Then we have to ask again, is the blood sugar high enough? Is that the blood sugar at the level that we want it to be? And if it's not high enough, then this loop will continue. If it's too high, then we're going to start the other negative feedback loop that has insulin in it. So during this lecture, we've covered what homeostasis is, what positive and negative feedback loops are, and gone into detail about a specific example of blood sugar in the body as a negative feedback loop. Next week, we're going to be talking about diabetes and what happens when this system gets deregulated. So make sure to spend some time on this because we're going to continue building on it next week. And thank you guys, and see you then.